Let's have a look at OCR's AS paper 1 from 2018. That's the pure and stats paper. So we start off, let's have a look. We've got our formula sheet just in case we need it. And then we're going to start with question 1. We're going to be expressing 3 to the power of 7 over 2 in the form a root b. So that's going to look something like this. So I'm going to start off with the fact that I'm going to have that as being a to the 7. In fact, no, I'm not. I'm going to have that as a to the half all to the power 7. So I'm going to use that power law backwards, put the brackets back in. The 3 to the half is root 3. So that's the power 7. So that means I've got root 3 times 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 root 3, 1, 2, 3, 4, 5, 6 times root 3. Each of those pairs is going to be 3. So 3 times 3 times 3, that's 27 root 3. So is that in the form a root b? Yes, it is. A is an integer, it's 27, and b is a prime, it's 3. Part 2, I've got root 2 over 1 minus root 2. I need to get rid of that denominator, so I'm going to rationalise the denominator, and this time I'm going to multiply by 1 plus root 2 over 1 plus root 2. It's that conjugate pair on the bottom, so we don't get those middle terms when we expand the brackets. So we're going to get on the top root 2 times 1, which is root 2 times root 2, which is 2. On the bottom, it's a difference of 2 squares, or it's that conjugate pair. 1 times 1 is 1. Then I'm going to have minus root 2 squared, so that will be minus 2. That is going to give me then, I'm going to put the number first, 2 plus root 2 over minus 1, which tidies up to be minus 2 minus root 2. And you can double check that on the calculator if you wish. Let's do that. So I've got root 2 over 1 minus root 2 is minus 2 minus root 2. So that's a good sign. We've got that one correct. Right, moving on then. Question 2. The equation has repeated roots. So that's something really useful. Should be looking for repeated roots. And then if we see that, we know that means that b squared minus 4ac is equal to 0, using that rule about the discriminant. So in this first one then, I've got a is 1, b is 3, and c is k. B squared minus 4ac equals 0, so that's going to be 3 squared minus 4 times 1 times k is equal to 0. So 9 is equal to 4k with a bit of rearranging. Just divide through by 4. K is 9 over 4, or 2.25. If we're asked to solve the inequality then, we have got 6 plus x minus x squared is greater than 0. Now, it's a little bit easier. We can do this just in the calculator. If we're not going to do it in the calculator, it's potentially a little bit easier if we have this so that we don't have negative x squared. It's just a little bit easier to factorise. So if I bring all of those across to the right-hand side, so I get 0, and then I'm going to have x squared minus x minus 6. I then want to find those critical values, which I'm going to do by factorising. So two numbers that multiply to be minus 6 and add to be minus 1. So I've got x and I've got x. I'm going to have minus 3 and positive 2, which means that my critical values are x is equal to 3 or x is equal to minus 2. I'm going to do a quick sketch to see what this looks like. So now I've got U-shaped, I'm going through 3 and minus 2. So it's going to look something like that. 3 minus 2, and I can pop in, I've got minus 6 as my y-intercept as well. According to this version, I want where we are below 0. So 0 is greater than this. So the bit where we are below 0 is this region here. So I can see that's for any values of x between minus 2 and 3. So I'm literally going to write x between minus 2 and 3 and then pop in the inequalities. Again, you can double check this, and you should double check this on the calculator. Most of them now have inequality modes on them. This one is there. I can say this is degree 2, and the original equation was of that first form. It would have minus 1x squared. It has 1x, and it has 6. We solve that, and we get exactly the same thing as we had in our solution that we worked out. Okay, so let's put that back into normal mode. We'll go back on to the next question. Bit of trig for us now. So we have got sine squared equals 0.25, and we're going between 0 and 360. So if we've got sine squared is equal to 0.25, then the first thing we're going to do to get around this problem is we're going to square root it. So that means that sine theta is going to be plus or minus 0.5. Plus or minus is really common for people to forget, so you do need to make sure you've got both of those, and we're going to solve both of those at the same time. So sine theta is 0.5, or sine theta, or rather and, not or, and, because both of these are true at the same time, sine theta is minus 0.5. So I'm going to get two sets of solutions. You should know the inverse sine of 0.5. That's one of those exact trig values, and that is that it's 30 degrees. We know we need to find in a range between 0 and 360. So let's have a look at the graph and see what that tells us about finding these other values. So I've drawn a few bits of the sine graph. If I draw a line across at half, I can see I've got an intersection just there, which gives me my 30 degrees, and I have another intersection there. And by symmetry, I know the distance from where it crosses the x-axis again, that's 30 degrees. So this is going to be 30, sorry, the distance from where it crosses is 30. So this is going to be 30 degrees in front of that 180. So that is 150 degrees. If I do minus 0.5, well, again, I happen to know this one is minus 30. So I would draw that at minus a half, and that gives me that value there. That's my minus 30 degrees. I'll draw my line across to see where the others are. Going to use that symmetry once again. So I'm going to have 30 degrees in front of 360 and 30 degrees after 180. So I have 210 degrees and 330 degrees. Minus 30 degrees is not in the range, so I'm going to get rid of it. It is important that if it's not in the range, you don't give it as a solution, but it should be visible to see that it was something you did consider. Part 2 then. So it says detailed reasoning. You can't just shove this into a solver. We have got that tan of 3 phi is root 3. Now again, you might know tan of inverse tan of root 3, but let's do it anyway. So inverse tan of root 3, that's 60 degrees. So we know that 3 phi is 60 degrees. Remember, we are going to inverse tan first and then do the division by 3. But because we're going to divide by 3, we need to triple our range that we're looking for answers in. So remember, every time we get a new solution, we're going to add 180 degrees. So I've got 60, let's add 180. It's 240. And we do it again, just to have a look. That's 420. Each of those we are then going to divide by 3. So that phi is 60 divided by 3, that's easy, that's 20. 240 divided by 3, that's 80 degrees. And 420 divided by 3 is going to be 140. That is not in the range that we're looking for, so I'm going to ignore it. I've just got the two solutions, 20 and 80 degrees. Right, let's move on. Question 4. It is given that y equals x squared plus 3x, and we've got to find dy by dx. So we've got a nice straightforward differentiation question. So if y is x squared plus 3x, dy by dx, multiply by the power, reduce the power by 1. So that would be 2x plus 3. Dead simple, 2 marks. Find the values of x for which y is increasing. Well, an increasing function means that I have a positive gradient. So that means increasing functions are when dy by dx is greater than 0. We have an expression for dy by dx, so therefore 2x plus 3 is greater than 0. 2x is greater than minus 3, so x is greater than minus 3 over 2. And all values of x greater than minus 3 over 2 will be increasing. Part 2, we're being asked to integrate. I'll do it over on the side. So we are doing the integral of 3 minus 4 root x dx. 4 root x, not very helpful, so let's rewrite this as the integral of 3 minus 4x to the half dx. Now I am integrating. I'm going to drop any integral signs and any dx's. They've been used. So that 3, we increase the power by 1. So 3, that's at the moment is x to the 0, so that becomes x to the 1. And we divide by that new power, so that is just 3x. The next one, I increase power, so a half becomes 3 over 2, and I divide by that. So minus 4 divided by 3 over 2. Let's have a look what that is. Minus 4 divided by 3 over 2 is minus 8 over 3. So I get minus 8 over 3x to the 3 over 2. And because this is indefinite integration, I need plus c. And that's it. Question 4 done. Question 5. N is an integer that is not divisible by 3. So if that's the case, then n is of the form either n is 3n plus 1, so that's 1 more than a multiple of 3, or n is 3n minus 1. That's the easiest way to do it. You could alternatively do it as n is 3n plus 2, and you could follow exactly the same steps as we're going to do, but the maths is just a little bit more complicated in terms of expanding. So if n is 3n plus 1, that means n squared is 3n plus 1, 3n plus 1, which is 9n squared plus 6n plus 1. Now, if we look at the form we want it, it's not very obvious why it's 3p plus 1, but then you can see, well, I can take a factor of 3 out of those first two terms, leaving me with 3 lots of 3n squared plus 2n. I have a plus 1 on the end, and we know n is an integer, and because we know that's an integer, that means 3n squared plus 2n is also an integer. So 3n squared plus 2n, I'm going to call p for convenience sake. So this is therefore 3p plus 1. I am then going to do a similar sort of idea. If n is 3n minus 1, n squared is 3n minus 1 squared. I'm going to expand the brackets, get a very similar result, and do exactly the same sort of idea. So that is going to be 3 lots of 3n squared minus 2n plus 1. Exactly the same interpretation. N is an integer. 3n squared minus 2n is also. And I'm just going to use the idea exactly the same again. And then I would write a concluding statement that proves this. This proves that if n is an integer not divisible by 3, n squared is of the form 3p plus 1. Just for completeness sake, if you've decided to do it with 3n plus 2, let's look at the algebra for that, see how that works. So if n is 3n plus 2, that means that n squared is 3n plus 2 squared, which is 9n squared, and you can have 3 times 2 times 2, so that's plus 12n plus 4. Now, it's not obvious here why we have the plus 1 on the end, but what we can do is we can say, well, this is 9n squared plus 12n plus 3 plus 1. And then by the same logic, 9n squared plus 12n plus 3 is an integer. You can write that as p. You can take out a factor of 3. You get a similar sort of statement. So it works for both cases. Right, question 6. We need to sketch the following curves. So the first one, 2 over x. We just need to know the shape of that. And the shape of that is it looks something like this. You need to have your axes, you need to have the two curves that have asymptotes, nothing crossing any lines. Apart from that, you don't need to mark off any intersections because there aren't any. Part 2 is a little bit more tricky. We can see that it is a cubic. And if we've got a cubic, we kind of know the basic shape, but we need to know, have we got any roots? So on this, let's look for some roots. X cubed minus 6x squared plus 9x equals 0. You could stick it in the solver on your calculator. You could factorise it, which I'm going to do here. So I've got x as a factor, x squared minus 6x plus 9 equals 0. So I've got x, two numbers that multiply to be positive 9 and add to be negative 6. I'm going to have x minus 3, and I'm going to have x minus 3. So I get that repeated root. So I have my roots at x is 0 and x is 3. That one repeated root means it just bounces off. So it's going to go through 0, 0, and then it's going to bounce back up off 3, 0. So it's going to look something like that. And I'm just going to mark off that that goes through 3 there. There is no y-intercept because there's no plus on the end, and we know one of the roots is 0, so it has to go through 0, 0. Question 7. Move the screen slightly. So we have a parallelogram with OA is A and OC is C. P is the midpoint of AC. We're being asked to find A to C first. So A to C is going along that diagonal line. So that would be going backwards along A. So that is minus A. And then it's going forwards along C. So that is plus C. O to P, let's find a journey to do that. So O to P, I could go from O to A. And then I could go from A to P. And then I know that A to P, because we don't know what that is yet, but I do know that that's half of A to C. O to A is A plus a half of C minus A. I'm just going to rewrite the first one just to make it a little tidier. If I expand and tidy up that, I've got A plus minus a half of A. So A minus half of A is a half of A, and then I've got plus a half of C. It then wants me to prove the diagonals of a parallelogram bisect one another. Well, one diagonal one is AC. And AC we've already worked out is C minus A. We did that at the start of the question. AP we've already worked out. And we've already said that is A to P is a half of C minus a half of A, or a half of AC. So we know, and we kind of knew that already from the description. We knew that P was in the middle of AC. What we want to do now is show that P is in the middle of OB, because that's the other diagonal. And if it is in the middle, then this will bisect each other because it's in the middle of OB. We know P is in the middle of AC. So if it's in the middle of both, it's on both lines. So that will prove that it bisects. Bisect meaning cut exactly in half. Right, so diagonal 2, this is the trickier one. Let's move that just to one side. Diagonal 2 then is O to B. O to B, well, that's going to be A plus C. We already know O to P from the work we've done in the last question. That is a half A plus a half C, which we can see is a half of OB. A half of OB. So therefore, as P is in the center of both diagonals and on both lines, this proves the diagonals bisect each other. Right, question 8. Another detailed reasoning. So the lines y equals a half x and y equals minus a half x are tangents to the circle. So let's draw what that looks like. So there's my axes. A half x is going to look something like that. Minus a half x is going to look something like that. And we're tangents to a circle, so I'm going to have a circle that looks something kind of like that. And that's negative a half x. If I want to find the equation of the circle, I need to know what the centre is, and I need to know the radius. I can see from symmetry that the centre is going to be on the y-axis. So my x-coordinate of the centre is going to be 0. I also know that if I draw a radius, because this is a tangent, that should be at 90 degrees. And if my diagram was any good, it would be. So I think we need to find the equation of that tangent. So what do we know about this? Well, this blue line, which I'm going to call the tangent, so the gradient of the tangent, well, that's going to be negative 2, because it's negative 1 over a half, because gradient and tangent and radius are at 90 degrees to each other. So we've got that. So this is therefore y equals minus 2x plus c. My other line, the green one, I'm going to call it MP. Now that's going to have a gradient of positive 2. So this is y equals 2x. Oh, and they meet at the same point, so 2x plus c. We've got anything useful here. So what can we find out? Well, we could make them equal to each other. That's not going to be very helpful, because if we make them equal to each other, we're not going to get y equals at all. We are going to get minus 2x plus c is equal to 2x plus c. And I'm just going to get that if x is 0, which it is on the x-axis, c equals c. Not very helpful. So why don't I take that blue equation and put it in the equation of the circle? So the equation of the circle is, so far, we know x squared plus y minus c, because we know the y coordinate of the centre is at the centre of the circle, which is the y-intercept of the straight line. And that's going to be equal to x squared plus y squared is going to be equal to r squared. Wait, I've missed out key piece of information. I already had pieces of information. I knew this point down here was the point 2, 1. So if I take that blue equation, let's get rid of the green one, that's not helpful to me. If I have that blue equation, that means that what we're going to have, 1 is minus 2 lots of 2 plus c. 1 is minus 4 plus c. So 5 is c. So I therefore know the centre is 0, 5. What I can then do is, if I know that is 0, 5, I can find the length of that blue dotted line. So my radius, r squared, is going to be, what's that? Y2 minus y1 all squared. Plus x2 minus x1 all squared. So that's Pythagoras again. So what have we got for y2? We have got 1 minus 5 squared plus, and then I've got 2 minus 0 squared. So let's see what that is. 1 minus 5 squared plus 2 minus 0 squared, which is 20. So the radius is root 20, but we're not asked that. We just asked for the circle. So that is x squared. Don't need a bracket, that's just habit. X squared plus y minus 5 squared equals 20. Right, I think that's the end of the pure questions. Let's move on to the stats questions. So, question 9. Jo is investigating the popularity of a certain band amongst students at her school. She decides to survey a sample of 100 students. States an advantage of using a stratified sample rather than a simple random sample. A stratified sample will ensure proportional representation. That just means that everybody gets their views represented proportionally. So we don't get 99 year sevens, for example. You would get, let's say, if you had the same amount of people in each year, 20 year sevens, 20 year eights, 20 year nines, 20 year tens, 20 year 11s. Explain why it would be reasonable for Jo to use her results to draw conclusions. It would not be reasonable her school may belong to a particular demographic that likes unusual music styles. And I think that's a fairly reasonable sort of suggestion. If you were at school in inner city London, you might have different um, music tastes to if you were in a school in rural Hertfordshire or down at the tip of Cornwall or up at the top end of Scotland. So where you live in the country might have things, and it might just be that her school is not representative of the UK. Notice that it wasn't explained, so I said it wasn't reasonable and then gave a reason why. The previous statement, I could just write something down, and I did. 3 words, that's just stating. Right, probability distribution of a discrete random variable is given in the table. We know it's a discrete random variable because these are the only values it can take. We're asked to find the value of p. So this question should be one of those questions that you're getting loads of marks for, because you know that all those things in the table are the only options that you can have in your probability distribution, so they all have to add up to 1. So therefore, 3/8 plus 5/16 plus 4p plus p is equal to 1. So what's that going to be? 5p is going to be 1 minus, and let's get the calculator to add fractions so I don't make mistakes. 1 minus 5/16 minus 3/8. So that gives me that 5p is 5/16. So therefore p, which is what we were asked to do, divide that by 5, is a 16th. Right, what I'm going to do now, and it hasn't asked me to, sometimes it does, sometimes it doesn't, I always would, is just refilling the table with these probabilities. So 4p is 4 over 16, and then p is 1 over 16. The values of x are chosen at random. Find the probability that the product of these values is 0. Well, the first thing I'm going to do is I'm going to draw a two-way table as a sample space diagram just to show me what outcomes I can have. I have to be careful because my outcomes aren't equally likely. Can't just count the outcomes like you might have done with 2 dice at GCSE, but I can use it to give me some idea of how many different ways there are of doing each combination. So dice 1 can have a 0, a 2, a 4, and a 6, 0, a 2, 4, and a 6 again. I'm finding the product of these values, so 0, 0, that's 0, 0, 0, 0, 0, 0, and then anything else is going to be non-zero because I'm going to have 4, 8, 12, etc. 8, 16, 4 sixes are 12, 24, 12, 24, and 36. So the ones I'm interested in are these ones. So how can I do this? Well, I could have the probability of getting a 0, 0, plus I could have 2 lots of the probability of getting 0, 2. 2 lots because I could have 0, 2 or 2, 0. The probability of getting 0 and 4, same reason why we have 2 of them, plus probability of getting 0 and 6. So the probability of 0, 0, well, that's going to be 3 eighths times 3 eighths plus 2 lots of 0 and 2, well, that would be 3 eighths for the 0 multiplied by 5 sixteenths for the 2 plus 3 eighths for the 0, 4 sixteenths for the 4 plus 3 eighths for the 0 and 1 16th for the 6. So I'm going to pop all that into my calculator. So it's going to be a bit messy, bear with me. So 3 eighths times 3 eighths plus 2 times, I'm just going to type it all in, 3 eighths. You know what? 3 eighths is a factor as well, so I'm going to take that out just to speed this up in the calculator. And then I'm going to have 5 sixteenths plus 4 sixteenths plus 1 16th. Close, close. I make that 39 over 64. Question 11. Probability that Janice sees a kingfisher on any particular day is 0.3. She notes the number x of days in a week on which she sees a kingfisher. State one necessary condition for x to have a binomial distribution. So you've got 3 things for it to be a binomial distribution. You have that you have a fixed number of trials, you have that the probabilities are independent, and the probabilities are consistent. You can pick any one of those 3 things. I'm going to go with fixed number of trials. 2, assume it is binomial. Find the probability that in a week Janice sees a kingfisher on exactly 2 days. So we have got x is distributed binomially. We have got 7 is my number of trials. And the probability that I get a kingfisher on 2 days, well, I've got 0.3 as my probability, and I'm looking for the probability that x is 2. That I'm going to pull straight from my calculator. So I want my distributions. This is a binomial PD because it's the probability distribution function. I'm going to put my variables in. X is 2, n is 7, and the probability is 0.3. So the probability that x is 2 is 0.318 to 3 significant figures. Each week, Janice notes the number of days on which she sees a kingfisher. Find the probability that she sees a kingfisher on exactly 2 days in a week during at least 4 of 6 randomly chosen weeks. So we're going to use the results we've just had to come up with a new binomial distribution. In this one, we're going to call this distribution y because we've already used x. It's still binomial, and the probability, we're going to do this 6 times because she's doing 6 weeks. And the probability of success, our success here is getting kingfisher on exactly 2 days of the week. So our probability is 0.318. We are looking for the probability that y is greater than or equal to 4, which is fine, except our calculators can't do greater than or equal to 4. So I'm going to calculate 1 minus the probability that y is less than or equal to 3, which it can calculate. So this is going to be 1 minus, so let's pop in, let's go back to our menu. I want distributions again. I want the binomial cumulative distribution variables. I'm going to put x is 3. My n is 6 trials this time, and my probability is 0.318, which gives me 1 minus 0.914, which gives me an answer of, drop it back into normal mode, 1 minus answer 0.0857. Question 11. Hypothesis test. Like a hypothesis test, 7 marks that you should be getting each time. It is known that 20% of plants of a certain type suffer from a fungal disease when grown under normal conditions. Some plants are grown using a new method. A random sample of 250 of these plants is chosen, and it is found that 36 suffer from the disease. Test at 2% significance level where there is evidence the new method reduces the proportion of plants which suffer from the disease. So, we've only got one hypothesis test to do on an AS paper, so that is a binomial. So we know that x is therefore distributed binomially. I'm going to have a sample of 250, and the probability of that is 0.2. We need to define our null hypothesis, and that is that the p is 0.2, and our alternative hypothesis is that p is less than 0.2, where p is the proportion, not probability, proportion of plants with the disease. I then want to find the probability that I get 36 or fewer. So the probability that x is less than or equal to 36, because this is what I'm going to compare with. What's the probability that I get 36 or fewer plants with this disease? So CD variable, I want 36. I want n to be 250 and probability 0.2. When I do that, I get this to be 0.014. So this is 1.4%, which is less than 0.02. That's significance level. So what this is telling me is that this happens rare enough. This is rare enough that it doesn't just happen all the time. So there might be something else going on. So what we can say here is this is less than the significance level. So there is evidence to suggest that H1 is correct. There is evidence to suggest that the new method reduces the proportion of plants with a disease. And with that, we've compared it to the significance level. We've identified whether we should accept or reject H0, H1, the non-alternative hypothesis, and then we've given an answer in context. Last question then. Question 13. Radar diagrams. Never seen a radar diagram before this exam question. Never seen one since. This is what we've got to do, is just try and interpret real graphs. So, radar diagram illustrates some population figures from the 2011 census. We've got Liverpool and we've got Rutland. So instantly I know Liverpool's a big city. I don't know Rutland, but I don't think it is. Each radius represents an age group as follows. So radius 1 is the 0 to 17-year-olds, 2 is the 18 to 29s, and so on. So I think from this I can see that Liverpool has just over 100,000 18 to 29-year-olds and about the same number of 30 to 44-year-olds. The distance of each dot from the centre represents the number of people in the relevant age group. Good, that's what I thought it was. The scales in the diagrams are different, state an advantage and a disadvantage of using different scales in order to make comparisons between the ages of people in the two local authorities. So, let's read that again. Advantage and a disadvantage of using different scales. Well, the advantage is you can compare proportions. Compare proportions. Disadvantage, you get no direct comparisons. I'd give that. If the mark scheme says anything different, I'll check it and make a correction. Approximately how many people aged 45 to 59 were there in Liverpool? So that is radius 4. I think that's just less than 100,000. So I would be saying something in the region of about 90,000 people. State the main two differences between the age profiles of the two local authorities. So what have we got? Well, Rutland has a high proportion of children. So that's one thing we can say. It's a higher proportion of children. And number two, well, what's the other one? Main two differences. Adults tend to stay in Rutland for their entire adult lives, because you can see that the ratings for 3, 4, and 5 are pretty consistent, and they're the ones for the adults. So it looks like we have kids. It looks like people go away from Rutland to university to go and get their first jobs, and then they come and settle down in Rutland and they stay here for their entire adult lives, where they've got kids and they can start to raise that family. Liverpool, people don't tend to leave. You can see that they start to die off a little early, because those 60 to 74-year-olds, they start to drop dramatically. So the second one we're going to say for Rutland is that adults leave for uni but come back to raise families. They never leave Liverpool, except to die, apparently. James makes the following claim: assuming there is no significant movements of population either into or out of the two regions, the 2021 census results are likely to show an increase in the number of children in Liverpool and a decrease in the number of children in Rutland. So in 10 years' time, each of these would move around. So what we're going to say, an increase in the number of children in Liverpool, potentially. Use the radar diagrams to give a justification for this claim. So, there are more young adults in Liverpool in 2011. These will have babies, so could justify about the increase in Liverpool kids. There are few in Rutland in 2011 to have kids. So again, potentially justifies the claim.